fluid coding, and AI. GitHub now has a Copilot native coding model that is supposed to be fast, efficient, and built for everyday repo work. So the question is not, is it the smartest model on a leaderboard? The question is, can the cheap native default get a real issue to green before the premium model earns its cost? The trap is thinking one prompt equals one price. Agentic coding does not work like that. A single request can trigger repo search, tool calls, test runs, retries, large context reuse, and a final diff that still needs review. GitHub now prices Copilot usage through AI credits based on input tokens, output tokens, and cache tokens. That means model choice, prompt shape, and agent behavior can all become workflow economics. MAI Code 1 Flash is not just another model listed inside Copilot. Microsoft describes it as built end-to-end by Microsoft, trained with clean and appropriately licensed data, and designed around the GitHub Copilot production harness. The model card lists a sparse mixture of experts transformer with 137 billion total parameters, 5 billion active parameters, a 256,000 token context length, and training from March through May 2026. At launch, it rolls out first in VS Code through Copilot. The pricing delta is large enough to matter. GitHub lists MAI Code 1 Flash at 75 cents per million input tokens and $4.50 per million output tokens inside Copilot. GPT 5.3 Codex in Copilot is listed at $1.75 input and $14 output per million tokens. Claude Opus 4.6 is listed higher again on both input and output, so if routine tasks work on the native model, the savings are not theoretical. The provider benchmarks are useful, but they are not the verdict. Microsoft reports MAI Code 1 Flash at 71.6% on SWE Bench Verified and 51.2% on SWE Bench Pro in its own model card. OpenAI reports GPT 5.3 Codex at 56.8% on SWE Bench Pro Public and 77.3% on Terminal. Bench 2.0 at high reasoning effort. Those numbers help set expectations. They do not tell us the cost of one accepted patch in your repo. The fair test is simple. Take one routine issue with an objective test oracle. Reset the repo to the same starting state before every run. Use the same prompt every time, fix the issue, keep changes minimal, run the relevant tests, and report remaining risk. Then run it through 3 systems: MAI Code 1, Flash in Copilot, a premium frontier model in the same Copilot surface, and a non-Copilot coding agent such as Codex. Correctness is only the first column. For workflow economics, record first pass result, number of steering prompts, visible token or credit usage, wall clock time, files touched, diff size, deleted lines, and whether the model found and ran the right tests. Also record review burden. A model can pass tests and still be expensive if it rewrites unrelated files, hides the real fix in a broad diff, or needs a senior engineer to untangle the patch. Copilot Auto makes the comparison more interesting. GitHub says Auto routes tasks based on complexity and real-time system health, with the goal of saving higher-cost reasoning models for work that needs them. Paid users also get a 10% model cost discount when using Auto in supported Copilot surfaces. But Auto is not a magic cheap model guarantee. The test still has to record which model actually answered after each response. The non-Copilot agent is not just another model slot. OpenAI describes Codex as a workflow for supervising agents across app, command line, IDE, and cloud, with isolated word trees and diff review. That can be a better fit for long-running or parallel exploration. It can also make the comparison less apples to apples because the ergonomics are different. So the question is not only which model wrote better code, it is which workflow produced the cheapest reviewable patch. The hard part is that agent cost is volatile. An April 2026 RxIve paper found agentic coding tasks can consume about 1,000 times more tokens than code chat or code reasoning tasks. Repeated runs on the same task varied by up to 30 times in total tokens, and higher token use did not reliably improve accuracy. That is why the test needs caps. Stop after a fixed prompt budget, a usage ceiling, or a patch that is green and reviewable. My expected routing rule is conservative. Start with the fast native Copilot model for small scoped bugs, narrow refactors, and focused tests. Escalate to a premium Copilot model when the task is ambiguous, multi-file, or reasoning heavy. Use an external agent when isolated branches, longer runs, or parallel attempts are worth more than staying inside the editor loop. The winner is not the smartest model. The winner is the lowest cost path to a correct, local, tested patch. If this comparison helped you think about coding agents as workflow economics instead of model hype, like the video and subscribe to Fluid Coding and AI. More tests like this are coming, with a focus on what actually gets code reviewed, tested, and shipped.